So we're going to solve the equations, and we're going to solve it using factoring or using the square root method. Now, we've already seen the square root method when we did Pythagorean theorem. But the difference is when we did Pythagorean theorem, we never kept the negative square root. When we solve these equations, we will keep the negative answers. So we'll have to be very careful when we get to the square root method. So when we solve by factoring, we need to get all the terms to one side, set our equation equal to 0, and make sure it's in standard form with the x squared, then the x term, then the constant equals 0. Then we'll factor the equation, which is what we did last week, and then we'll set each term, which will be each parenthesis, equal to 0, and then solve for the variable. So let's take a look. Now, these first two examples, and you're going to get the same thing in the homework, they are already factored for you. We don't need to distribute and then have to go back and refactor it. It's already factored. So this is one of your terms, the x, and you set it equal to 0. And then we'll take the second term, which is the x plus 3, set it also to 0. Now the green one's done. That's our first answer. But we have to solve the second equation by subtracting 3. And then the other answer is x equals -3. So the first couple in the homework, they're already factored for you. You just set each one of the terms equal to 0 and solve for the variable. Next one is exactly the same thing. I'm going to set 5x equal to 0. This one I'll divide by 5. And you have to recognize that when there is a 0 in the numerator, you get 0 as the answer. If 0 were in the denominator, if you were trying to divide by 0, that would be undefined. And then take the second term, the 3x minus 2, set it equal to 0. So I'll add 2. 3x equals +2. Divide by 3. And the other answer is x equals 2/3. So you can get 0 as an answer, and you can get fractions as an answer. Now, if you notice, whenever we start factoring these, you're going to end up getting either one answer, two answers, or no answer. Now, these all had 2. And just to show you a little preview of what's to come, and if you actually graphed quadratics in your Algebra 1 class, these answers we're getting are actually our x-intercepts. So for example, this first one, this would have told me that my graph is going to touch the x-axis at 0 and then also at -3. And then if you were to graph it, it might look something like this. Quadratics all take on either a U shape or an upside down U shape. Now, if you had only one answer, then what that might be is your graph is just sitting on the x-axis. Or if you end up with a question where it's no solution, then that might mean your U is way up here and it never touches the x-axis. Now, you don't need to worry about graphing any of these. This is just a little review and a preview of what's to come when you take Algebra 2 next year. Right now, all we're doing is trying to find the value of x, because what we're going to be using is what we're learning this week. When we're solving these quadratics, this is what's going to happen in Chapter 10. When we start looking at the circles and some of the sides or some of the segments in our circles are going to have a variable squared. So we're going to end up with a quadratic equation that we're going to have to solve. So let's go ahead now and let's look at what we did last week. And we have a quadratic equation. It's set equal to 0. So now my next step is to factor it. This is what we did last week. So this is the nice, easy one. Remember, this is in standard form. It's the ax squared plus bx plus c. So when it's got the 1 in front, when your a value here is a 1, all you have to do is find the factors of the c term. And in this case, it's the 6. That will sum to give you the b term, which is the -5. So if I start making my list of factors of positive 6, this is a clue that the signs are the same, and they're both going to have the sign in the middle, which is negative. So negative 1 times negative 6, well, that gives me negative 7 when I add them. It's not what I need. But if I do negative 2 and negative 3, that's what I need. So I can go right into my binomials, x minus 2, x minus 3. Now, this is what we did last week. Now we have to take it one step further, and I set each of my binomials equal to 0. So x minus 2 equals 0, and then x minus 3 equals 0. I'm going to add 2. X equals positive 2, and then add 3 on this one, and x equals positive 3. So we're taking it one step further. After we factor it, we set our factors equal to 0. And that will give us our solutions. Let's try the next one. Remember, it needs to be set equal to 0, so I need to get it into standard form. So I need to add 15 to both sides. And now I have x squared minus 8x plus 15 equals 0. So now I'm looking again, nice and easy. I'm looking for factors of positive 15 that will sum to give me that b term, which is negative 8. So if I start my organized list, and again, signs are the same, so it's both got to be negative. This gives me negative 16. This one doesn't work. Let's try the next one. 2 doesn't work, but I can do 3. Negative 3 times negative 5. And when I add those, it gives me the combination I need. So this is going to be the combination. So again, I can go right into my binomials. So x minus 3, x minus 5. Now we take each factor, set it equal to 0. Take this one. I need to add 3. X equals positive 3. And x equals positive 5. And there are your two solutions. Now, remember, when we did the homework last week, the instructions up here said factor. Now what's changed is the word here, instead of factor, it says solve. But you have to factor first, and then from there, set your factors equal to 0 and solve for your variable. Let's try the harder trinomials, where the number in front of x squared was not a 1, and we have to do the factor by grouping. For this one, it's the harder trinomial because the number in front of x squared is not a 1. So you could either guess and test here, or I always like the grouping because usually it's faster than doing a bunch of FOIL problems. So I need to multiply the beginning and the end. So I'm doing 3x squared times negative 8 gives me negative 24x squared. These are the factors that I'm looking for. And then I'm looking for what will sum to be negative 2x. So if I start my organized list, in order to get a negative product, I need signs that are different. So, and the sign in the middle is the bigger factor. So it's 1x times negative 24x. When I multiply that, I get the negative 24x squared. But when I add it, I get negative 23x. Not what I need. So let's try 2. 2 times negative 12. That gives me negative 10. Not what I need. If I try 3 and 8. And it's a negative 8, but still, it gives me a negative 5. Still not what I need. Let's try 4. 4 and negative 6. This gives me the sum and the product that I need. So I'm going to take these and replace the middle. So let me come over here to the side so I got lots of room. So I'm going to rewrite the first term, the 3x squared. I'm going to replace the middle with the two factors I just found. which are going to be the positive 4x and the negative 6x. Doesn't matter the order that you put them in here. And then rewrite the last term. So now I'm going to make groups. So I can do a blue group here. And let's just do a black group so it shows up. So the GCF of my blue group will be 3x. Divide it. The GCF of the second group will be positive 4. Divide it. And now take what's in common, the x minus 2, and then also put the two GCFs together. And this is what we had done last week. But now we take it one step further, and I set x minus 2 equal to 0, and the 3x plus 4 equal to 0. I need to add 2. So my first answer is positive 2. And then here I'll subtract 4 and divide by 3. So x equals negative 4 over 3 are my two solutions. Next one, we need to get it in standard form. So I'm going to add 3. And now I have 2x squared minus 5x plus 3 equals 0. Again, I've got a number in front of my x squared, so I need to factor by grouping. So I'm going to go ahead and multiply the beginning and the end. So I'm looking for factors of 6x squared that will sum to give me negative 5x. So if I start my organized list here, signs have to be the same. So if I do negative 1x times negative 6x, that gives me negative 7x. That one doesn't work. But if I try negative 2x and negative 3x, that gives me the negative 5 that I need. So again, I'm going to replace the middle, this negative 5, with these two factors I just found. So rewrite the first term. I'm replacing the middle with these two. So the negative 2x and the negative 3x. It doesn't matter the order that you place them. You'll get the same answer either way. And now I'll make my groups. My greatest common factor of the first group is 2x. Divide it. The GCF of the second group. Now, if you pull out a positive 3, what remains after you divide will not match. So the better GCF, so you get the match, will be a negative 3 GCF. You'll divide it. And now, these look the same, which is our goal. So now I take what's the same, these guys, write it once, and then take the two GCFs, and that becomes the second binomial. And again, if the instruction said factor, this is where we would stop. But the instruction said to solve, so we need to set it equal to 0. So take the x minus 1, set it equal to 0. Take the 2x minus 3. Set it equal to 0. Add the 1. X equals positive 1. Add the 3. Divide by 2. And x equals 3 over 2. You don't need to make it a decimal. You can leave it as a fraction. It would be 1.5 as a decimal. So this was solving using factoring. So you'll use one of the factoring techniques we learned last week. You will factor if it's a trinomial and get the two binomials. Or if it's the difference of two squares, you can either factor it or use the square root method, which is what we're going to see next. So next, what we're going to do is solve equations by square rooting. So whenever you want to use the square root method, you're going to get the square term to one side of your equation. Then you'll square root both sides, and you're going to put, if you want to put the shortcut, which is this symbol plus minus, this is just saving you from having to write the answer one as positive, one as negative. We did this technique when we did Pythagorean theorem. However, when we did Pythagorean theorem and we would solve for a c, or even an a squared or a b squared, we would always keep the positive answer only because we never wanted a negative side of a triangle. However, now when we're looking for solutions of quadratics, we're going to keep both answers. And I'll show you what I mean by that. Let's go ahead and take a look at our first example. I have x squared equals 4. Now this one is perfectly set to use the square root method. All I have to do is take my equation, square root both sides, and the square root of x squared is just x, because square rooting a square cancels it. Now, here's where, when we square root the 4, we're going to get both the positive 2 and the negative 2 as an answer. When we did this with Pythagorean theorem, we would have only kept the positive 2. But now, technically, whenever you solve for a variable squared, it has two answers. So you can either write it with the plus minus or separate it, and it's x equals negative 2 and x equals positive 2. This symbol that's right here is just a shortened version of having to write down both answers individually. Now, the other way that we could also solve this is we could use the instructions that we had for factoring, set our equation equal to 0 by subtracting the 4, and now I have a binomial, which is the difference of two squares, which I could factor. So this factors into x plus 2 and x minus 2. I don't care which method you use. And then now what we need to do is, just like before, set each of our factors equal to 0. So subtract 2, and x equals negative 2, add 2, and x equals positive 2. So you can either just use the square root method or set it equal to 0 and then factor the difference of two squares. We can do exactly the same thing on the next one. I can either choose to just go right into my square root method, square root both sides, and x equals the square root of 9, positive and negative 3. Now, you will not be using a calculator for this quiz. So you'll have to do all of this by hand, looking for the factors and square rooting it. They'll be perfect squares. They won't be very large. Now, the other way to do this same problem would be to subtract the 9, turn it into the difference of two squares, and then factor it into x plus 3, x minus 3. Set each of the factors equal to 0. Solve for each. So this is how you get negative 3 and positive 3. If you use the square root method and you forget to put both positive and negative as the answer, you're going to lose half of the points because you left off one of the solutions. So just be very careful. All right, next one. Again, this one is set up to be factored, but we could move it over, and I'm going to show you both ways again. This will factor. Square root of 36 is 6, so it'll factor into x minus 6, x plus 6. Set each of the factors equal to 0. And now solve for each. So x equals positive 6 and x equals negative 6. And again, this is how you're going to have to enter the answers, not with the plus minus symbol. But be aware of that because that symbol shows up on SATs. Now, the other way that we can also solve this is instead of leaving it like that, we could have also added the 36 and used the square root method. So once we get that on the other side, square root, but always remember, it's going to give me both positive and negative 6 when I solve for a variable squared. So you can either separate it or use that nice little symbol on the quiz. In the homework tonight, they're going to make you enter them individually. Next one. Again, this one is not a perfect square, so I can't factor it. So what I would need to do here is move the 10 over. X squared equals negative 10. And then now I'm going to square root both sides. But if you remember probably back from your Algebra 1 days, you can't square root a negative number. This answer is no real solution. What it gives you is an imaginary solution. And more than likely, you did not cover imaginary numbers in Algebra 1. You'll learn about imaginary numbers in Algebra 2. This answer, if it asked to list all solutions, it would actually be x is equal to positive and negative I square root 10. But you don't need to know this. All you need to know that the answer is no real solution. Now on the quiz, every question is going to have a solution. I'm not going to give you anything that doesn't have a solution. Let's say instead the problem was x squared minus 10. So if that's the case, we would do this. We would do x squared equals 10. We would still use the square root method, but on the quiz, what you're going to do is you would break down the radical. 10, it just turns into 2 times 5. There's no pairs, so you would just leave it as positive and negative square root 10. Tomorrow, when we do the quadratic formula, Big Ideas is going to want you to use your calculator. However, for the quiz, we're leaving our answers in simplest radical form because we're not using calculators for the quiz. So for the next one, now again, we can do this 2 ways. We can either decide to subtract the 47, set it equal to 0. So I get x squared minus 64 equals 0. Factors of our square root 64, it's the difference of 2 squares, becomes x plus 8, x minus 8. I need to set each of my factors equal to 0. So x plus 8 equals 0, x minus 8 equals 0. Subtract the 8. My first answer is x equals negative 8. And then the second answer is x equals positive 8. Now, if you prefer, you could also, instead of move the 47, you could move the 17. So either way, if you do that, you get x squared equals 64, square root both sides, and then x equals positive and negative 8. Same answer I got when I factored it. So either method is acceptable. Next one is exactly the same thing. I can either choose to factor it. If I choose to factor it the way it's given, I need to factor out a GCF of 4 first. Always look for a GCF first if you're using the factoring technique. Once I divide them both by 4, I end up with x squared minus 36. I now have the difference of 2 squares. I got to keep factoring. So here, x minus 6, x plus 6. And now we set each one of the factors equal to 0. Now, if I set 4 equal to 0, this is nonsense. It will never happen. So I don't do anything with that. But then I'll take the next one, the x minus 6, set it equal to 0, and the x plus 6. So this one adds 6. X equals positive 6. And this one's x equals negative 6. Now, if you chose to do the square root method, so if I take the problem, and instead, if I'm going to use the square root method, you have to isolate the square term. So I would need to move the 144 over. This only works when it's a binomial, not with a trinomial. Then divide, still isolating the square. So now I have x squared equals 36. And then now I square root and get x equals positive and negative 6. For example, where maybe it's not a perfect square. All right, so let's say instead it was 4x squared equals 20. So I can't factor this, but I could use my square root method and then get x squared equals 5. 5's not a perfect square, so if you get a question like this on the quiz, you're just going to leave your answer as x is equal to positive and negative square root 5. This one, remember when you're using the square root method, you need to isolate the square term. It's isolated. So now all I have to do is square root this side and this side. When you square root a square, it cancels it. So then now you're left with x minus 2, and then the square root of 9 is positive and negative 3. Now, we can't leave our answer like this. So when this is a perfect square, I need to turn this into two problems. I need to do x minus 2 equals negative 3, and then x minus 2 equals positive 3. Add the 2. X equals negative 1. Add the 2, and x equals positive 5. So when you're using this square root method, you need to make two problems if you've got something else going on that's added or subtracted to the x. Same thing on the next one. I'm going to just use my square root method because my square term is isolated. So if I square root this side and this side, remember square rooting the square cancels it. So the 2x plus 1 comes out. And then over here I get both positive and negative 5. And now I need to make two problems. 2x plus 1 equals negative 5. And 2x plus 1 equals positive 5. Subtract the 1. 2x equals negative 6. Divide by 2. X equals negative 3. And then over here, subtract the 1. Divide by 2. And x equals 2. So there are your two answers. So again, you're going to be factoring and then setting the factors equal to 0. Or when you get to the difference of two squares, you can either factor it or use the square root method. The beginning questions in the homework are already factored for you. So just set each term equal to 0 and then solve for the variable. And that is it on the solving equations using factoring and square roots.